Have you ever looked up at the night sky and wondered about our place in the universe? We live on a tiny blue planet, a speck in the vast cosmic web. But what if our location is more unusual than we thought? Some scientists believe we might be inside a gigantic empty bubble, a cosmic void. This idea could help solve one of astronomy's biggest puzzles, the Hubble tension. Imagine our galaxy not in a crowded cosmic city, but in a quiet, empty suburb. If true, this could change how we measure the universe's expansion and explain why our numbers don't match up. The universe is a tapestry of dense clusters and vast voids, and we may be in one of the emptiest neighborhoods. Let's explore how this cosmic address could be the missing piece in understanding the universe's expansion. The answers may be hidden in the patterns of the oldest light in the cosmos. Imagine two speedometers in your car. One says 67, the other 73. Both are accurate, but they disagree. That's the Hubble tension. Two precise ways to measure the universe's expansion, but two different answers. One method looks at nearby stars and supernovae, cosmic mile markers, giving a higher value for the Hubble constant. The other studies the ancient light from the Big Bang, the cosmic microwave background, predicting a lower value. Both methods are solid, but the difference is too big to ignore. This isn't just a small error, it hints at something missing in our understanding of the cosmos. Are we missing a key ingredient, or is there something odd about our place in the universe? The Hubble tension is a clue. Pulling on it could unravel a new understanding of everything. Scientists are searching for what's causing this cosmic disagreement. Could our location in the universe be the answer? What if the Hubble tension is all about where we are in the universe? The cosmic void hypothesis suggests our galaxy sits inside a vast, underdense region, 1 billion light-years wide. In crowded regions, gravity slows expansion. But in a void with less matter, expansion speeds up. It's like being in the fast lane of the cosmic highway. Our local measurements show a higher expansion rate. This means our speedometer is reading high because of our emptier surroundings. The true average expansion rate of the universe could be lower, matching the value from the cosmic microwave background. If this is right, the Hubble tension isn't a problem with physics, but with our perspective. Our cosmic address might be skewing our view of the universe. Sometimes the answer is as simple as where you're standing. To test the void idea, we turn to the universe's oldest sound, the echoes of the Big Bang. In the early universe, space was a hot, dense fluid, carrying pressure waves, cosmic sound waves. These waves, called baryon acoustic oscillations, BAO, rippled through the primordial plasma. When the universe cooled, these waves froze in place, imprinting their pattern on the cosmic microwave background. Today, we see these ancient ripples as tiny temperature variations in the CMB. The size of these ripples gives us a standard ruler to measure cosmic distances. This ruler is fundamental to understanding the universe's geometry and expansion. By studying these patterns, we can test if our local measurements are biased by our cosmic neighborhood. The sound of creation still echoes, offering clues to our cosmic puzzle. The universe's oldest light may hold the answer. How can ancient sound waves help solve the Hubble tension? The BAO ruler shaped how galaxies are spread out today, leaving a faint pattern in their positions. By mapping millions of galaxies, astronomers can see if this ruler looks different inside and outside our supposed void. If we're in a void, the BAO pattern would show a unique distortion, a signature of our local environment. Telescopes like DESI are mapping the universe in 3D, searching for this pattern with incredible precision. If the BAO ruler changes across our cosmic neighborhood, it's strong evidence we live in a void. The answer to the Hubble tension could be hiding in this data. Whether we're in a void or not, this search is pushing the boundaries of what we know. We're listening to the echoes of creation to understand our place in the cosmos. The universe is stranger and more magnificent than we ever imagined.